Physics chapter 25 theory video 1. So we are going to discuss about motion of charged particles. So there is some relationship. There's a big relationship rather with the electric fields and magnetic fields that we have learned so far. So you need to know that a current carrying conductor in a uniform magnetic field would experience a magnetic force F, and then you can understand the factors that would affect F, this force F. So the strength of the magnetic field, the distance, all of those things you need to know. And then if there are two parallel oppositely charged parallel plates, we can get equations for electric field strength E. So you have to know, you have to recall what you have learnt in capacitors as well. So moving particles, electrons, protons, neutrons, positrons, and many other different particles are there. Lot of these particles are positively or negatively charged. Then they, if they are charged, they have the ability of influencing electrical and magnetic fields and also causing the different fields. So then by their deflections or how they vary in their path when subjected to a different attraction or a repulsion from a different other charge would give us an idea as to what these particles are. So how these charged particles behave in an electric or magnetic field is actually what we can understand from this lesson, and also we figure out how they can be controlled and how charged particles can be used for different benefits and for different experiments that we conduct. Then also they will allow us to learn new things about these charged particles itself, and figure out the things that we have not yet discovered. Now before we start off, there is something that you really must understand, that is, by convention, the direction of electric current is the direction from positive charge, that is, flow of positive charge, positive to negative. Remember that when electrons are moving, you are talking about conventional current in the opposite direction, that is, the electrons move from negative to positive. So that relationship you need to know, because most of these theories are based on the conventional current. Now when you use an electron gun, that is a beam of electrons, and if we use that, if you use that electron beam in a magnetic field and how that magnetic field or a magnetic field would be affected by the electrons, or how electrons are affected by the magnetic field, is what we refer to in these things, and we are trying to find out how they are affected. Now if we change the strength and direction of a magnetic field, and also if you reverse the field, what would happen is what we are trying to see. Now in this particular situation, there is a beam of electrons coming from the right hand side. In this direction it is coming. Then this electron beam goes into a magnetic field that is as a result of this electrons flowing into the that is the electricity going into, there is a conductor carrying current into the page. So then this magnetic field is there, and that magnetic field results in a force that turns the electron beam, that turns, so it is affected in a way. So that means electron beams are repulsed. So there is a negative charge here and a positive charge somewhere. So that is the somewhere at the top. That is what you need to realize. So in a basic sense, you would have a positive charge somewhere here, because that is the reason why electron beams get attracted towards that side. Or else there is a negative charge. There is a negative charge here, therefore it gets repelled to the other side. Right. So that is the basic principle that you know. Now let's figure out how these forces are created, and what rules that we can use to figure out in which direction it is going to get forced. Right. The force on the electrons that is moving through a magnetic field, we can use Fleming's left hand rule to find the direction of the force. Now the electrons move from right to left, where a magnetic field is directed into the plane of the paper. So the magnetic field is into the paper. Because electrons are negatively charged, they actually represent the negative. The current is from left to right. Right. So the electrons are moving. This electron beam is moving in this direction. So the magnetic field is into the paper. So what happens is, we have to figure out. Now we know the field direction we know, then the direction of this is direction of the electron. So the direction of the current is in this direction, because we take the conventional current. It is the opposite side of the direction of electrons. I hope you understand that. So now we know that we use Fleming's left hand rule, and we can figure out in which direction the force is going to be. Because when electrons enter the field, the force will be upwards, and it will get deflected up the page. When the direction of the force will also change, when they go out of the field, it will actually go straight. So this is what gives rise to the motor effect. So the electrons in a wire will also experience this force when they go through a magnetic field, and this force is what, now you know, when there is a conducting wire, this is made up of electrons. So as a result, this would get bent upwards because of the force. That is how the force acts. So here we are talking about a single beam of electrons, just like how electrons pass through in this beam. So now let's try to see this practical activity and how that gives us this idea of the theory behind this. So now here this is a vacuum tube that is used to find how the electron beams are affected. So this electron beam tube has an electron gun which has a heated cathode. When they have sufficient thermal energy, it will jump out of the cathode and have the ability to travel towards the anode, which would attract the electrons. Now, when they go through the anode, they produce a single electron beam. A narrow beam goes into the space beyond that. We can change this direction of the beam by using an electric field between the two plates. Or else we can use magnetic electromagnetic coils, and using the electromagnetic fields we can create a change in that. Right. So obviously, in this particular situation, what happens is there is a heated cathode. From that, electrons jump, and through the anode it goes. Only a single beam goes out. It will get diverted depending on what sort of a effect is there. So that is basically what you need to learn, and what you should be able to explain. Right. So you have to remember Fleming's left-hand rule, and you should be able to figure out in which direction the effect is going to be. I would suggest that you do question number 1 before we move on to the next part. But before that, let's write down a note on what we have learned so far. Write down: matter is made up of different types of particles, and charged particles they contain can be affected by magnetic or electrical fields. Magnetic or electric fields. Put a star and write down: the conventional current can be regarded as the opposite direction of flow of electrons. The opposite direction of flow of electrons. Write down. In below situation, leave a line and write. In below situation, an electron beam fired into a magnetic field is pushed upwards, within brackets, right? Direction can be understood by using Fleming's left-hand rule. And please draw this diagram. Draw 25.3. Draw 25.3, and once you have, after you have done it, write down: using an electron beam tube, where a heated cathode can be used to produce an electron beam, which would allow us to observe the effect of changes in magnetic or electric fields produced by charge plates or magnetized coils. And please draw this 25.4. Once you have completed that, please do question number 1. If you have any doubts, please ask. so I can explain it further. In the next video, we will discuss how magnetic force on a moving charge, how the magnetic force affects the moving charge particle.